So next we calculate the air. Okay, the mass air into the system is actually okay. Bismillahirrahmanirrahim. So we continue with the example. Okay, so determine the air fuel ratio for 1 kilomole of octane burned with air containing 20 kilomole of oxygen, and we assume complete combustion and there is an excess of oxygen exists in the products. Alright, so let's draw the diagram for this case. So you have your combustion chamber. Okay, this is fuel, and this one is air, right? Okay, air. So the fuel is octane. So for octane, it is actually C8H18, okay, combined with air. So meaning O2 plus 3.76 and 2. Okay. So the product of the reactant, this one is reactant, C8H18 plus air is actually the reactant. Okay, this one is the product of combustion. So the product of combustion, since this one is air, so meaning you're gonna have CO2, H2O, and N2 plus there is information here, there is an excess of oxygen. Okay, so let's put some value here in order for us to calculate later. So X, Y, Z and value. So basically what you can from here, what we're gonna do is we're gonna write down the chemical equation, right? So C8H18 plus 20, okay, because we have 20 kilomole of oxygen. 20 O2 plus 3.76 N2. So you're going to have XCO2 plus Y H2O plus Z N2 plus W O2. So this one is multiplied by 1, right? Because we have 1 kilomole of octane, so multiply by 1. So next, what we do, we do the balance equation. So we start with carbon. So take a look at carbon. Alright, so you have the value at the left hand side and at the right hand side. So for carbon C, right, so you're gonna have 8 equals to X. So meaning X is actually equals to 8, right? So that's for carbon. Next is for H. So for H at left hand side, you're gonna have 18, right? So this one equals to this one. At the right hand side, you're gonna have 2y. So meaning y is actually 9. So next we do the O. So oxygen. Okay, just the O. Okay, for O is 20 multiplied with 2. Okay, can put it something like this. 20 multiplied with 2 equals to, this one is at the left hand side, right? So at the right hand side, you're gonna have 2x plus y plus 2w. Okay, 2w. Okay, so since we know that x known, the value of x is known, so 2 multiplied by 8 plus y is 9 plus 2w. So from there, w is actually equals to 7.5. Next we go to N. Okay, we solve for N. So N is 20 multiplied with 3.67, and then at the right hand side is Z multiplied with 2. So from there you're gonna have your Z is actually equals to 75.2. Okay, so we substitute all these values into the first equation here, right? So we're going to replace x, y, z, and w. So what you're going to have is this one, right? So we have C8H18 plus 20 O2 plus 3.76 and 2, and then this one is equals to x. Now we already have the value of x. Okay, so x is 8 CO2 plus y 9 H2O plus Z is 75.2 N2 plus W is 7.5. So that is the balance equation. So next we want to calculate the air fuel ratio. The mass of air divided by the mass of fuel. So here, how we calculate this one is by the number of moles multiplied by the molar mass of air for air, and the number of moles multiplied by the molar mass for fuel. Okay, before that, for air, the N is actually equals to 4.76. Mole. This one you can refer to the psychometric chart. And this one is M for air is 29 kilogram per kilomole. Okay. Next, when we talk about carbon, the N or M. Okay. So the N for carbon for octane is 8. Right, this one. This value. Okay. And then the M is 12 kilogram per kilomole. Next is the H2. Okay, so we are talking about H2, not H. So since we are talking about H2, so now the number of N is actually equals to 9, right? So 9 multiplied by 2 is actually 18, and the molar mass for hydrogen is 2 kilogram per kilomole. So this value M, you can refer to the property table. So for air, standard, oxygen plus N2, the value for N is 4.76, right? So next you calculate the air. Okay, the mass air into the system is actually 20 multiplied with the number of N, which is 4.76, and then we have the molar mass, it's actually 29. Right. So now we divide the fuel. We have carbon, and then we have hydrogen. So for carbon, 8 multiplied by 12 plus hydrogen is 9 multiplied by 2. Okay, so that's how we calculate air to fuel ratio. So from there, the value that we're gonna get is 24.2 kGa per kg fuel. So just a recap back, alright, for air, the N is 4.76. So everything at the front here, you need to multiply with that value. So for this case, it's 20 multiplied with 4.76, and the molar mass for air is 29. Okay. Next, carbon. Okay, so for carbon, since the number of N is 8, right? So this one is 8 multiplied with the molar mass for carbon, which is 12 kg per kilomole. So this is the value. Next, we use hydrogen, not H but H2, right? So since this is H2, our value here is H18, right? So the N now is actually 9. Okay, 9 multiplied by 2 become 18. Because we want to use the molar mass of H2, 2 kg per kilomole. So from there, we determine the actual value of air to fuel ratio is 24.2 kg dry air per kilogram fuel. Okay, so that's all. Assalamualaikum warahmatullahi wabarakatuh.